Hello, geometry class, and welcome to this video on section 10.8, the power theorems, which sounds a lot cooler than they actually are. I mean, to you, I think they're cool, but that's me. All right, anyway, so the first theorem talks about two chords intersecting inside of the circle. Now, we've done a lot of work talking about the angles that are formed and the arcs that are formed and the relationship between the angles and arcs, but now we're looking at the lengths of the chords themselves. So this says if two chords of a circle intersect inside the circle, then the product of their measures of the lengths, of the segments of one chord equal the product of the measures of the segments of the other chord, the chord power theorem. Okay, now what does that mean? The way I have it drawn, it's like, green piece times green piece equals red piece times pink piece. All right, so try to get the colors to kind of match up. All right, so the two chords get split. Now they don't get split in half, but the way they get split, piece times piece equals piece times piece. Okay, that's what this says. Now, why is this true? Well, the power theorems all come from similar triangles. So what I'm going to do is I'm going to draw in two chords to make triangles. So there's VL and there's SN. Now, why are the triangles VEL and SEN congruent? That's going to be what we're going to try to prove. EVL and ESN. Why would they be not congruent but similar? Well, certainly they have the vertical angles here. Those two angles are congruent. And then if you notice, angle V intercepts arc LN. So whatever LN is, V is half of it. What angle also intercepts LN? Angle S does. So angle V and angle S are inscribed angles that are both intercepting arc LN. So they are half of the same arc, which means they're congruent. So by angle, we get that triangle EVL is similar to triangle ESN. When we have similar triangles, we can set up a proportion. And the proportion is VE is to LE as ES is to EN. And then we can go from the proportion to cross multiplying. And there we have VE times EN equals LE times ES. And there is where that comes from. Okay, so let's use it. This should be pretty straightforward. So we want to find X. And I have two chords that intersect, and I'm going to use the chord power theorem. So 6 times 2 is equal to 3 times X. So 12 is equal to 3X, so that means that X is 4. Okay, very simple application. That's when two chords intersect. Now, let's take a look at when we have a tangent and a secant. So if I have the circle O, P is an external point, and I draw a tangent from P to Q. So PQ is tangent to the circle, and then a secant, just any secant segment that starts at P and hits the circle in two parts. So here's the official wording, and rather than just read that, what I want you to think of is the secant or the tangent secant power theorem says outside part times the whole thing equals outside part times the whole thing. So for the blue secant segment, the outside part is PS and the whole thing is PU. So outside part times the whole thing equals, for the tangent, the outside part is the whole thing. So PQ times PQ. And what do I mean by the outside part, right? So P to S, that's all external. That's not in the circle. So PS is the outside part, and PU is the whole secant segment. So outside part times the whole thing equals, for the tangent, outside part times the whole thing. Just so happens that the tangent segment is both the outside part and the whole thing. Okay. This proof is a little bit trickier, but it's still not too bad if you know which segments to draw in. So I'm going to draw in QU, and I'm going to draw in QS. And I'm once again going to prove that two triangles are similar. Now, which two triangles? PQS and PUQ. Now, why are they similar? Well, first of all, they share angle P. So by the reflexive property, angle P is congruent to itself. So we have one angle. Now, notice angle SQP. That is this angle right here. That is formed by a chord and a tangent, and that is going to be half of arc SQ. What else intercepts SQ? Well, that's angle U. That's an inscribed angle. So angle U is also half of arc SQ. So since angle U and angle SQP are both half of the same arc, they have to be congruent to each other. So by angle, triangle PQS, that's this one here, is similar to angle PUQ. That's this one here. And from that similarity statement, we get the proportion PQ is to PS, PQ is to PS, as PU is to PQ, PU is to PQ. And cross multiply, PQ times PQ, that's PQ squared, PS times PU. And we get that statement there. Oh, forgot the dot. Boop. So outside part, PS times the whole thing, PU equals outside part times the whole thing. All right, let's use this in an example. All right, so we want to find y. Y is the tangent segment. So outside part is 2. The whole thing is 2 plus 16, which is 18. And that is equal to outside part times the whole thing, which for the tangent, the outside part and the whole thing are both y. So 2 times 18 is 36, and that's equal to y squared, square root, y is 6. Okay, so please be careful. It's not 2 times 16. It's outside part times the whole thing. That's where the 18 comes from. All right, one last power theorem, and that's if we have two secants. Now, what happens if we have two tangents? Well, that's a two tangent theorem. They're congruent to each other. So that's why that's not in this section. We already have seen what happens when we have two tangents. Okay, so again, here's the wording. I'm not going to go through the wording. What we end up with is outside part times the whole thing equals outside part times the whole thing. So for this secant segment here, the outside part is PA, and the whole thing is PB. So outside part times the whole thing. For the other secant segments, this guy here, the outside part is PC, and the whole thing is PD. So we want to show why outside part times the whole thing equals outside part times the whole thing. Okay, let's get to work. Again, it matters which segments that we draw in. And I'm going to draw in the segment BC, and I'm going to draw in the segment DA. And I'm going to show that the triangles PBC and PDA, they're not congruent to each other, but they are similar to each other. So why is it that triangle PBC and PDA are similar to each other? Well, once again, they share angle P, so they're congruent to each other, right? That's the reflexive property. Now, angle B and angle D are both inscribed angles that intercept arc AC. So they're both half of whatever arc AC measures. So they also have to be congruent to each other. So once again, by angle, I have the two triangles are similar to each other. And if I get similar triangles, I can set up a proportion. PB, the whole thing, is to PC, the outside part of the other secant segment, is to equals PD, the whole thing, over PA, the outside part of this secant segment. So I can cross multiply and get outside part times the whole thing equals outside part times the whole thing. All right, let's use this secant power theorem in an example. All right, so I have two secant segments. I can say for the outside part times the whole thing, which is not 8, it's 12, is equal to outside part, which is 3, times the whole thing, which is z. All right. So 4 times 12 is 48, and that's equal to 3z. So that means that z has to be 16. Now, just be on the lookout for questions that might ask, well, what's this part? And you have to say, okay, if the whole thing is 16, then what's this part? It's 13. And maybe if instead of calling the whole thing z, if they called just that part w, how would you set up your equation? Well, you'd say 4 times 12, it's still outside part times the whole thing, equals 3 times 3 plus w. And solve it, you get w is 13. Can get a little trickier. They may ask for that piece there, and then you might have to set up a quadratic, which hopefully factors. You might also see questions that go through the center and ask to find a radius. Okay, so these problems will get tougher. I just wanted to give you a little bit of a brief overview of these 3 theorems. So we have 2 secants, outside part times the whole thing equals outside part times the whole thing. 2 tangents, a secant and a tangent, outside part times the whole thing equals the tangent squared. And then 2 chords, which is just piece times piece equals piece times piece. All right, guys, we'll see you next time.